Okay, so in this video we're going to have a quick look at buses and registers. So we've looked at already how the fetch, decode, execute cycle works and how data is transferred in and out of these buses, out of these registers using these buses. Okay, but what we need to know is what the registers and buses actually do. So give it some type of definition. So we'll start off with the program counter. Right, now the program counter, it just stores the address of the next instruction to be carried out. Alright, remember the important thing here is it's an address and it's not an instruction. Alright, so it stores the address of the next instruction. Move this along. That's the next instruction. Okay, next up we have the memory address register. Alright, now very similar to the program counter, with one very important slight difference, is it stores the address still of the current instruction being carried out. Okay, so this one will be the next, this one's the current, which means once the instruction's gone into the memory address register, the program counter can talk up to the next instruction to be carried out. And the next one, we'll have a look at the control unit. Now the control unit it controls everything that's going on. Alright, so it's relatively simple what the control unit does, but at the same time probably the most complicated because it's controlling everything. Alright, so it's just controlling the flow of data. Now the memory data register, which is here, it stores the data that is currently being carried out. Okay, so it stores the actual instruction. Just realize that it stores with a double S. It stores the current so that's the information, it's the data itself, alright, the actual instruction. Now you have a current instruction register, which is, sorry, it just keeps not changing my pen. The current instruction register, it just stores a copy of the current instruction. Now I know this, when you look at it on face value, this looks like the current instruction register is a little bit pointless. But if you remember, if there's specific instructions that ask the memory data register or the CPU to store something inside the RAM, and then you loaded something up and then you stored something, the memory data register would lose its contents, which means the current instruction register would keep it and still be able to carry out the instruction once something's been stored or loaded up. Alright, now we have the arithmetic and logic unit. Alright, don't know why my pen doesn't change, but I'll look at that later. And this one, it just carries out all the mathematical and logic calculations. Okay, so it basically does maths and logic. And then finally you have the accumulator. This one is actually stored inside of the arithmetic and logic unit, and it's basically, it stores the output of the instruction. And they they are the registers. Right, now let's have a look at the buses. Right, so there's three main buses that we need to look at. The first one is the address bus. The second is the control bus. And the third is the data bus. So let's have a look at what these do. So the address bus, it carries addresses from the memory address register to the RAM. Yes, register to the RAM. Alright, now the control bus, this one here. Now the control bus, remember, it's going all over the place. It's pretty much connected to everything, and it basically sends control signals. Right, these control signals are telling what registers what to do and where to send things and when to do it. And then finally you have the data bus. Now the data bus is different to any other bus because you'll notice it goes both ways. This is because you can send data into registers and you can send data back into the RAM. Alright, so it sends data. Okay, now I'm going to put here can be from RAM, and it can be to RAM. It's the only bus that goes both ways, the data bus. Alright, so that is the registers and buses inside the CPU. If I zoom out there, and if you want, you can take a screenshot of that.